In this video, you'll see how to solve multi-step inequalities. The big thing to remember is when you're solving an inequality, you're going to do basically the same things you would do when you would solve an equation. So when I see this first inequality, 6a minus 7 is less than or equal to 17, I want to isolate a on one side of the inequality symbol. So the first thing I want to do is zero out the constant. I'm going to add 7 to both sides of my inequality. I get 6a is less than or equal to 24. Finally, to isolate a, I want to get a all by itself, so I'm going to divide both sides by 6, since 6 is multiplying by a in my inequality. And my final answer is going to be a is less than or equal to 4. Finally, I want to graph my inequality, make my number line. 4 is my boundary. I see that it is less than or equal to 4, so since it's or equal to, I'm going to fill in my circle. And what numbers are less than or equal to 4? All the numbers to the left of 4. So my arrow is going to the left. All right, here's another example. It may look a little more complicated, but just think about what you would do when you solved an equation that looked like this. Right? First thing we would think about doing is we think about simplifying this one side here of the inequality. So I've got 15 is less than or equal to, I'm going to use the distributive property. I'm going to multiply negative 2 times 4m and negative 2 times 7. So negative 2 times 4m is negative 8m. Negative 2 times 7 is negative 14. Then I'm adding 5. Then to keep simplifying, I'm just going to combine like terms. 15 is less than or equal to negative 8m. Negative 14 plus 5 is negative 9. And now I have an inequality that I can solve by zeroing out the constant. I'm going to add 9 to both sides. 15 plus 9, that gives me 24. 24 is less than or equal to negative 8m. Now here's the very important thing to remember about inequalities. I'm dividing both sides by a negative 8. What happens when I divide an inequality by a negative, or if I multiply both sides by a negative? Right? I have to remember to switch the symbol. So 24 divided by negative 8 is negative 3. But instead of less than or equal to, I've got to change that to greater than or equal to m. And last but not least, I want to graph my inequality. Negative 3 is my boundary. It's less than, or negative 3 is greater than or equal to m, so I want to fill in my boundary here. Now I want to think to myself, negative 3 is greater than or equal to what numbers? Oh, negative 3 is greater than or equal to all these numbers here that are to the left of negative 3. Okay, let's solve this next inequality. Notice there are variables on both sides, but what I want to do is I want to simplify the right side of that inequality as much as I can before I start moving things around. So I have 3w plus 12, and that's going to be less than negative 2w plus 7w is 5w plus 27. Now what I like to do next is I like to get the variable terms only on one side of the inequality symbol. And what I want to try to do is keep my inequality, to keep my coefficient positive so that I don't have to worry about switching the sign of the inequality. So I could subtract 5w from both sides or subtract 3w from both sides of the inequality. And I'm going to subtract 3w from both sides. And again, the reason I'm going to do that is because now 5w minus 3w, I get 2w plus 27. My coefficient's positive, so I know that when I divide, I'm not going to have to switch the sign. Next, I want to zero out my constant, which is 27. So this constant on the variable side, I want to zero it out. And I need to subtract it from both sides of my inequality. 12 minus 27, well, that's negative 15. And that's going to be less than 2w. And then finally, to isolate the variable, I'm going to divide both sides by the coefficient. I'm going to divide both sides by 2. So my final answer is negative 15 halves, or negative 7.5, is less than w. And I want to graph this inequality. I'm going to mark my boundary, negative 15 halves. And I want to think to myself, well, negative 15 halves is less than w. It's less than, so I need an open circle. So negative 15 halves. What's a number that negative 15 halves is less than? Negative 15 halves is less than 0, and 0 is over here. So I'm going to shade everything that's to the right of my boundary. All right, here's one for you to practice on your own. Hit pause in the video, solve this inequality, graph it please, and then hit play and see if you got the right answer. Okay, first thing you want to do is you want to simplify, if you can, either side of the inequality. So 4 minus 3p plus 2, I can rewrite that as 6 minus 3p is greater than 4 minus p. And now I want to get all my variables just on one side of the inequality. I want to keep the coefficient positive. So in order to keep the coefficient positive, I'm going to add 3p to both sides. 6 minus 3p plus 3p is just 6. And that's going to be greater than 4 minus 3p plus 3p. That is 4 plus 2p. I have a positive coefficient, which makes this a little bit easier to solve. I'm going to subtract 4 on both sides to start isolating my variable here. 6 minus 4 is 2. 2 is greater than 2p. To isolate the variable, divide both sides by 2. And I get 1 is greater than p. I want to graph my inequality. 1 is my boundary. It's greater than p, so I've got an open circle. 1 is greater than what numbers? 1 is greater than all these numbers to the left. So I fill it in to the left. And that's how we solve multi-step inequalities.